This is Pre-Calculus, Functions and Graphs. I'm Mr. Stark. We're on topic 5, Parametric Relations and Inverses. There are 7 topics total in this unit. And this is lesson 5a, Parametric Relations and One-to-One Functions. This is the 10th lesson of the unit. Just like usual, you can follow along using this document and using your TI-84 graphing calculator. We'll do a little tutorial. Parametric equations are pretty cool because you could graph all sorts of curves. It's one of my favorite things to study. They're defined by 2 equations, x equals f of t and y equals g of t. F and g are simply 2 functions that are dependent on the variable t, which is usually time. And you could have probably guessed this, but t is the parameter. Let's check out the example. Consider the set of all ordered pairs x comma y defined by the equations x equals t squared plus 2t and y equals t plus 1. So x is a quadratic function dependent on t, and y is a linear function dependent on t. You might recall that a relation is simply a set of ordered pairs, x comma y. So if we have equations that give us x values and y values, then we have ordered pairs. And if we have multiple ordered pairs, we have a set of ordered pairs, which is a relation. On to part A. Use a graphing calculator to find the points determined by t equals -3 all the way up to 3, and we'll create a table below. Jot this down. T min equals -3, T max equals 3, T step equals 1. Then let's create a table with 3 columns. The first column is for t, the second one is for x, the third one is for y. We'll fill this in later. Part B we'll do on the graphing calculator in just a moment, and you could always sketch a little visual here after we do that. Part C we'll answer after we see the graph. But let's do part D together right now. It says to find an algebraic relationship between x and y. And that means we need an equation that relates x and y without the variable t. So we need to solve one of the equations for t and plug in that expression into the other equation. I noticed that the y equation is a little easier to solve for t, so let's do that. If we subtract 1 from both sides, we get t equals y minus 1. Then we take that expression and plug it into the other equation as t. So we get x equals quantity y minus 1 squared plus 2 quantity y minus 1. That's it. That's a relationship between x and y. We could try solving for y if we wanted to, but that looks pretty difficult. Let's expand the right side of the equation instead. We get y squared minus 2y plus 1 plus 2y minus 2. The 2y's subtract out, and we get x equals y squared minus 1, which looks like the equation of a parabola. Follow along using your TI-84 graphing calculator. The first thing I do is go to mode, so I could change from function mode to parametric mode. I hover over parametric and press enter. Then we could go to y equals to enter the equations. And you'll notice that there's an x and a y that you could enter for. So what I see are 5 sets of parametric equations we could use. So the t button is where the x variable is. So t squared plus 2t. Then you go down to the y function and you enter that, so t plus 1. Then let's press zoom 6 and see what sort of graph that we get. Many times it's sufficient, but in this case, I'm not so sure. So we don't really know, right? Because we don't really know what that equation looks like. So let's hit window and make sure that it has a proper t-min. And look, it doesn't. So let's enter -3 and +3 for t max. And then remember our t-step was 1. So t-step is just how many steps to take, like how long your steps are. So if it's close to 0, you're taking a lot of steps. If it's 1, you're taking a step for every t value. And that's what we're doing, all of -3, -2, -1, and so on. So now we could see our graph, and we press trace, and then we could see the values that correspond to it. So enter those in your table, 3, -2. Then the one that corresponds to time equals -2. Oh, you have to press the right arrow, by the way, to move forward in time. 0, -1. -1, 0. And then we have 0, +1. So we keep pressing right, and it's moving along the curve. 3, 2, 8, 3. And the last one doesn't show up on the screen. It's past the screen, but we could still see it. 15, 4. We could still see the point. So that's the graphical way to see that. You can see the equations at the top. And now let's go to our table, but I'm changing the table set, so second window. So changing that to -3 for t, and then 1, like we did already. So second table. Now we could see the t values, the x values, and the y values, just like we have on our paper, if you're following along on that. So you could go down, and you could see the t values go up by 1, and you could see all the corresponding x values and y values for that specific parameter. So now what I wanted to do was change my window so I could see that last x value, or that last point. So -5 to 15. I didn't really need to change the -10. I could have left it. But then go back to the graph, and then you could see all that curve. So that's the parametric curve that corresponds to the time. And there's the last point. But if I wanted to see more of this, like, it looks like a parabola, then maybe I want to extend the time here. So if I go to a window, I could do that. And I'm just pointing out here that there are 2 y values that correspond to x = 0. So we know that it's not a function. Fails the vertical line test. So if I make the tmin and tmax different, make it a bigger window, then you could see more of the curve. So it's just showing the curve based on specific time values. So if you made time like -50 and +50 for the tmax, then you'll just see more of that curve, and you could extend your window. So sometimes when we sketch just part of a curve, we're not really sure what it is, but if we extend the tmin and the tmax, we could see more of it. The next lesson is all about inverse functions, how to find them and how to verify them. These notes about inverse relations are designed to prepare you for that. Here goes. The ordered pair A, B is in a relation if and only if the ordered pair B, A is in the inverse relation. What that means is switching the x and the y values is part of the inverse process. And the phrase if and only if means that the conditional statement works both ways. Here's the last thing. The inverse of a relation is a function if and only if each horizontal line intersects the graph of the original relation in at most one point. In short, if the relation passes the horizontal line test, then its inverse is a function. For example, the function x² is a function, but if we find the inverse of that function, it's not a function because x² does not pass the horizontal line test. But the function x³ is a function, and it does pass the horizontal line test, so its inverse is definitely a function. And in conclusion, if a relation passes the vertical line test, it's a function. And if it passes the horizontal line test, its inverse is a function. That's the end of Lesson 5A, Parametric Relations and One-to-One Functions. And hey, if you're taking physics right now, you can apply parametric equations to the path of projectiles. The x equation models the horizontal movement of the projectile, and the y equation models the vertical movement. The height of that projectile is affected by gravity, so you'll see a -16t² in terms of feet, or a -4.9t² which is in terms of meters. Okay, thank you so much for watching. Let me know if you have a question or comment.